Yesterday we talked about exponents with regular numbers. Today we're going to talk about them with numbers and with letters and how we can simplify using some rules instead of using the expanded form. We are going to start with the expanded form and then I will show you the rule. So on this first example, we have 2 squared times 2 to the third power. So you can see we've written out 2 squared, 2 times 2, and 2 times 2 times 2, which is 2 to the third power. And when we count these, we have 1, 2, 3, 4, 5. So over here, I can simplify that and write 2 to the 5th power, like we did with some of our numbers yesterday. If we were to expand on this next one, 3 to the 4th, 3 times 3 times 3 times 3, and then 3 to the 5th, 3 times 3 times 3 times 3 times 3. So when I count these off, I can see in fact that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can write 3 to the 9th power. What I want you to recognize is that if I have 2 to the 2nd power and 2 to the 3rd power, if I take my exponent of 2 and I add it to 3, I end up with my 2 to the 5th power. So that's what I want us to recognize. If I have 3 to the 4th power plus 3 to the 5th power, 4 plus 5 is 9 for my exponent of 9. So you can continue to write exponents as repeated multiplication, and then go to the power form. Or if you start to feel comfortable without having to write everything out and using the rule, then that may be a nice shortcut for you. We can do the same thing with letters. So this one has A's. So this A to the first, be aware, you're really going to just see A, right? That 1 is going to be invisible. So if I have 1, A to the first, I have A to the 4th, 3, 4, and then I have A to the 3rd, 1, 2, 3, and I count these off, 1, 2, 3, 4, 5, 6, 7, 8. I end up with A to the power of 8. Now again, based on what we were just talking about, if I have A and I add my exponents, 1 plus 3 plus 4, 1 plus 3 plus 4 is in fact 8, which was our exponent. Sometimes you have multiple letters, so we just need to take them in individual pieces. Again, if there's no exponent, please remember to put the 1. And you can group these together with like terms, or you can write them separately. So if I have x and then I have y squared, I have 1x and then I have 2y's. And then if I have x squared, that's 2x's and y to the first. So I can go through, I can say, okay, I have 2x's right here. So that is going to be x squared. And then I have 1, 2. Oh, that is not x squared. I missed an x. I apologize. This should be x to the 3rd. And then on my y's, I have 1, 2, 3 also. So I'll write y to the 3rd. So you can separate these. You can write x to the 1 plus 2, which I took from here and here. And then I have y to the 2 plus 1. So both of those give me my exponents of 3. Sometimes we have regular numbers involved. So regular numbers are just going to be regular math. They're not going to follow any of these special rules. So when I have regular numbers, we just want to write those, especially when they're different. If they were the same regular number, we could do it as an exponent. But because these are different, we need to write them separately. And then I have 9 x's, 3, 4, 5, 6, 7, 8, 9. And then I have 7. 1, 2, 3, 4, 5, 6, 7. And what I need to realize is regular numbers, regular math. Because those numbers do not match, like up here with the 2 and 3, those match. We could write them with an exponent. These are different big numbers. So big numbers, regular math. 2 times 3 is 6. And then I can say, okay, I have x to the 9 plus 7. I have 6x to the power of 16. And if I went through and I counted all of my x's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is where I get my exponent. So what we need to take from all of these examples is when multiplying exponent expressions with the same base means big number, right? We will need to add our exponents. Our exponents, remember, are our small number. We can also look at this in division. We did this a little bit with the regular numbers yesterday. So 2 to the third divided by 2 squared. So you can see in my numerator here, I have 2 written 3 times, 1, 2, 3, and 2 squared, 1, 2 on the bottom. Now we talked about yesterday that 2 divided by 2 is 1. 2 divided by 2 is 1. So really I'm left with 1 times 2, which is in fact 2 to the first. Now, because we are dividing, when we multiplied, we added. So the shortcut when we divide is going to be to subtract. 3 minus 2 gives me my exponent of 1. Because I had 2 2's on top and 2 2's on bottom, that simplified to be 1. So we can try this with the 3's. 3 times 3 times 3, 1, 2, 3, 4, 5, 6, 7 in my numerator. And I have 4 3's in my denominator. So again, like we practiced yesterday, we can expand these. These all become a 1. I'm left with 3 to the third power in the numerator. But the shortcut would be, and this division symbol is kind of like a big minus sign. 7 minus 4, going to be 3 to the third. We can do the same thing with letters. Okay, it gets a little, some people have trouble with that because they're used to regular numbers, but we can do the same thing with the letters. So I have x to the 6, so that's 6 x's. Y squared is 2 y's. I'm going to leave a little space in case I have extra on the bottom. And then I have 4 x's on the bottom, and I have 4 y's on the bottom. So remember, anything divided by itself, be it number or letter, these simplify to be 1. And I can see I'm left with 2 x's on the top, so there's my numerator, x squared. And I have 2 y's on the bottom. So now my denominator is y squared. So if we were to use a shortcut for this, x to the 6 minus 4, always numerator first minus denominator, and y to the 2 minus 4. So 6 minus 4 is my 2 on my x right here. Now, 2 minus 4 is a negative 2, which is why that exponent went in the bottom. And we'll address that a little bit more probably tomorrow. Sometimes we have regular numbers. So remember, regular numbers, regular math. So that's just a regular division problem. We're not going to worry about our letters. I'm actually going to write my letters separately over here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Over 8, 1, 2, 3, 4, 5, 6, 7, 8. So now I can go through. Anything divided by itself is 1. You could write those ones if you really wanted to. So I can see I have 4 y's left, and they are in the numerator. And 10 divided by 5 is 2. So remember, regular numbers, regular math. With the exponents, only the exponents, we can say 12 minus 8. Oh, I wrote a 4. It should have been a 2. Or a 2. I apologize. I wrote 2. It should have been a 4. I was not paying attention to that. So 2 y to the 4th. So when we're dividing with the same base, we need to end up subtracting the exponents. Just a few more examples so you can practice this. Sometimes when we have some bigger numbers, they get a little bit complicated. But if you take this step by step, you should not have any issues. If we expanded this, if we felt like that was something that we needed to do, we talked about yesterday about that whole distribution thing. I would put a 1 on my 4 here. So 5 to the 7, 4 to the 3rd, all over. We talked about 5 to 2 times 2, right? We talked about multiplying yesterday. So 5 to the 4th, and 1 times 2 is 2. So if we were to simplify this, we are dividing. So remember, when we divide, we need to subtract numerator minus denominator. And I'm going to actually have to do that 2 times because we actually have 2 powers there. So 7 minus 4 is 5 to the 3rd. 4 to the 3 minus 2 is 1. You don't have to write the 1, but if you wanted to. So when we look at this next one, again, regular numbers, regular math, you can just put that in your calculator. And when you do 7, so I'm going to expand it. I'm just going to write these as 2 separate things. And then we have 10 to the 6 minus 3. You could write out 10 sixes and, 6 tens and 3 tens and cancel that if you want it. Or we can just use this shortcut. 7.8 divided by 3 is 6. And 10 to the 6 minus 3 is 10 to the 3rd. So going back to what we talked about at the beginning, right? This is multiplying. So we're going to add. And again, if you would prefer to write this out as the expanded form and count, you could. So x to the 6th. Now this one does have regular numbers. Okay, there are no exponents outside, so we're not distributing. These are just another way we could write this is 2x to the 4th times 8x squared. So don't think those parentheses mean we need to distribute because there's nothing outside to distribute. Regular numbers, regular math. And then we can add our exponents. So 2 times 8 is 16. 4 plus 2 is 6. When we're dividing, again, regular numbers, regular math. 6 divided by 2. And then 7 minus 4. So 6 divided by 2 is 3. 7 minus 4 is 3. And here as well, remember, put a 1 when you don't have that exponent. So we have 12 divided by 3 and 1 minus 5. So we have 4. You can write p to the negative 4. Remember also, you have 1p on top and you have 5 on the bottom. So really this negative means that those are going to go in the denominator. So another way we could write this is that 4 in our numerator, p to the 4 in our denominator. Here we have some division. It's written with an old school division sign. So just remember the first one would go in the top, and we would need to do keep, change, flip. Or you could just write it out. This would go on, this is their numerator and this is our denominator when we look at it this way. That's probably an easier way to do it. So if you didn't want to write with the division sign, you can simply write it with a fraction bar. Don't forget to put your 1. Regular numbers, regular math. So we're going to have 10 over 2. These are going to be subtracted. So m to the 2 minus 4, n to the 4 minus 1. So when we simplify this, 10 divided by 2 is 5. 2 minus 4 is negative 2. And then 4 minus 1 is 3. So this one has some shapes to represent some things. So if this was like an edgephoria, it might have some shapes like this, and it wants you to do maybe a drag and drop on what those shapes are. So this, if we needed to label it, right, here's my box, M to the triangle, N to the circle. So my box is going to be my regular number, my 5. My triangle is -2, and my circle is 3. This last one is a little trickier. We talked about keep, change, flip yesterday in our notes. So keep the first one. And then change your divide to a multiply and flip your second one. So now I can see that I do, in fact, and if I wanted, I could rewrite this so that the same letters are together, if that helps you. So you can see the fact that you need to subtract. So we're going to say P to the 12 minus 7 is 5. R to the 12 minus 9 is 3. So my final answer is P to the 5. R. Oh, I wrote this wrong. I apologize. I'm having a hard time with that tonight, it seems. This is not a 12 on the R. It is, in fact, a 2. So let's make sure we write the correct number. 2 minus 9 is a -7, so R to the -7. Now that negative, and again, we'll talk about that some more in our next lesson, you can put it on the bottom as well. Both of these answers would be correct. See what you can do on your practice. Have a good night.